Hello, this is Mr. Collier, and today we're doing lines of best fit. So if you take a look at this data here, we have the relationship between the temperature outside and the profits of an ice cream company. So as the temperature increases, obviously the ice cream company makes more money. Okay, now these points don't exactly form a line, but as you can see, there's very close to a linear relationship here. Okay, so what we can do is we can draw a line of best fit to approximate the relationship, and we can make predictions about the profit of the ice cream company. So what I want to do is I want to use a point. It doesn't have to be the first point in the data set, but I want to draw a line so that I best represent this relationship. Now you don't want your line up here where all the points are underneath your line, or down here like this where all your points are above the line. You want it in between. Maybe hit as many points as possible, and you want to have the same number of points above the line and below the line. So here I have 3 points above and many points below. If I go down a bit, I got 3 points above and about 3 or 4 below. So I think there is pretty good. You got an equal number above and below the line. So I'm going to use that as my line of best fit. Now you or your friend might get a different answer on this one. If you used a computer, it has a method so that everybody who does it gets the same answer, but you or your friend might get a slightly different answer for these kinds of questions, because it's really all an estimate anyway. Okay, so what we're going to do, we have no idea what the y-intercept is or the slope right now. We could calculate these things, and we're going to have the equation of the line, which we're going to use to make predictions afterwards. Okay, so right now I'm going to pick 2 points on the line. I'm going to pick this point and this point right here. They're on the line, and I'm going to use those 2 points to find the slope. So this point here, I'm going to say that's 12 maybe, and 190. Okay, about that. And this point is 22, and the profit there is about 520. Okay, so I can use those to find the slope of the line. You can use your slope formula, y2 minus y1 out of x2 minus x1, and that's going to be, I'll do 520 minus 190 out of 22 minus 12, so that's going to be 330 out of 10, which equals 33. So your slope is 33, and what that means in this situation is as the temperature increases by 1 degree Celsius, your profit increases by $33. So every 1 degree Celsius that the temperature goes up, your profit increases by $33. Okay, so we got the slope, so we can write the equation line as y equals 33x plus b. Okay, so we don't know the y-intercept right now. We're going to find that right now. So we're going to substitute one of those points into the equation. So I'm going to pick this point here. Okay, 12, 190, and I'm going to substitute into the equation. Okay, the y value is 190, and the x value is 12. We use that to find the y-intercept. Okay, now if we do 33 times 12, we will get 396 plus b, and subtract 396 from both sides. Okay, so we do that, and we're going to get, oops, wait, there's a mistake here, that's 190. So we're going to take 190, subtract 396, and we get negative 206 equals b. Okay, so that's the y-intercept. Now if you look closely at the graph, it looks like the y-intercept would be right here, and it should be a positive number, but this is actually 10 right here. So the y-intercept is way over here. So it is possible that the y-intercept is a negative number. Okay, and in the context of this problem, actually this number, negative 206, doesn't really mean anything. It doesn't mean his initial profits are negative 206. It doesn't really mean anything in this situation. But we need that number for our equation and to and to do calculations later on. So I'm going to write the equation now. It's going to be y equals 33x minus 206. Okay, so now also you could write this as profit equals 33 times temperature minus 206. Okay, so you could also write like that if you want the real life situation in there like that. So that's our equation. Profit equals 33 times temperature minus 206. So we're going to use that now to make some predictions. So I'm going to write down that formula here before I forget. Profit equals 33 times the temperature minus 206. Okay. So how much profit would you expect the ice cream shop to make on a 21 degrees Celsius day? We can use our formula to make that prediction. Okay, so the profit equals 33 times 21 minus 206. And if we work that out, we're going to get 33 times 21 minus 206 is $487. So the profit equals $487. And maybe I should even use an approximately equal to sign here, because everything we're doing here is estimations anyway. It's not going to be exactly 487, but it'll be fairly close to that number. Okay, next question. How much money would you expect to make on a 30 degrees Celsius day? So that's a pretty hot day. We can expect a larger number. Profit equals 33 times 30 degrees minus 206. And if we worked it out, 33 times 30 minus 206 is going to give us 784. So let me put approximately equal to sign, and that's going to be about $784 on a 30 degree day. Okay, lastly, if the shop makes $500 in one day, estimate the temperature outside. Well, we can substitute that into our formula. That's going to be the profit, so it's going to be 500 equals 33 times temperature minus 206. And then we'll solve that equation for T. So we're going to add 206 to both sides. We get 706 equals 33T. And then we're going to divide both sides by 33. And 706 divided by 33, it gives us a temperature of approximately 21.4 degrees Celsius. Okay, so that's a good estimate as to the temperature you need to make a $500 profit in a day.